So what happens when we are unable to find a common base? Meaning that we won't be able to write this 7 as a base 3 expression. So we need to use logarithms. Logarithms, as you remember, have several laws, and one of those laws is the fact that if you have logarithm base n, meaning any base of a raised to the power of c, you can rewrite it as c times the logarithm base n of a. So just like when you have, let's say, the third is equal to 27, and you want to solve for x, you get the cube root of both sides. So you apply the same thing on both sides of the equation. So that's something that you can do here. We could find the square root of both sides, and that would still be an equality, but that won't get us anywhere because we're trying to solve for x. So one way to go here is to get a logarithm, and you can basically use any base, but we're gonna go for the natural logarithm or the common logarithm, so we can use our calculator in order to find the decimal approximation of x. So I'm going to go for the natural logarithm, and I'm going to write it as the natural logarithm. And in there, I'm going to have 3 raised to the power of x plus 2. And I'm still going to have the natural logarithm of 7. This will allow me to use this law of logarithms in order to set the x plus 2 free, to have it multiplying factor as x plus 2 multiplying the natural logarithm of 3, and we still have the natural logarithm of 7. That way we can solve for x now that we have that x out of the exponent. So x plus 2 is going to be equal to the natural logarithm of 7 divided by the natural logarithm of 3. And finally, x is going to be equal to the natural logarithm of 7 over the natural logarithm of 3 minus 2. So that is our exact answer. So I'm just going to reveal the process we just followed. And if you're asked the exact answer, you would choose this one right here. But if you want a decimal approximation, you would go to your calculator, type the exact answer, meaning that whole thing, and you're going to get a decimal approximation of your answer, meaning that if you substitute either of those two, this one will, if you substitute this version of the answer on the exponent, you're going to get exactly 7. So if you rewrite it as 3 raised to the power of the natural logarithm of 7 divided by the natural logarithm of 3 minus 2, and then plus 2, meaning that this is the x, this is the x right here, and then plus 2, that needs to give you 7. If you substitute this version of the answer, you're not going to get exactly 7, you're going to get something that's close to 7. So in this case, we go for the natural logarithm or the common logarithm. Either will get you the same. So this could also be written as the common logarithm of 7 divided by the common logarithm of 3 minus 2. And that will get you the exact same answer.